Okay, I'll start with this remaining things on the cluster, and then I'm planning to cover the small part, which is the web server. So these two topics that I'm having. So on the cluster, we will look at forum, fencing, and ordering of resources. So the agenda is actually we'll see how far we have gone. We have covered how much we have covered on the cluster, and we'll uh, go through the fencing, quorum, and other related configuration constraints, configuration, and the demo. So
Okay.
coming, yeah. So uh, coming to the okay. So how far we have completed? So first we have seen the SCSI setup, so that we had already seen, and we have seen the pacemaker HA cluster, its components and its basics configuration. We had also seen the cluster setup along with the cluster resources, and we also had a chance to see the resources being available during failover scenarios. Today we will be seeing the fencing, and we'll be looking at quorum, fencing, configuration, node level, web interface for pacemaker cluster. So these are the things that I'm planning to cover today. So we'll quickly move on. Okay, so what's a fencing? Fencing is basically in a cluster is basically a communication breakdown. It's basically a communication breakdown. Between the nodes. So because of the communication that got broken down, so the nodes would actually behave little inconsistently, and sometimes these nodes might try to access the cluster resources independently without being this thing mm, without being aware of without the other nodes being aware of. So such scenarios would lead to some disturbances and inconsistencies in the data. And so uh, so what happens in such scenario is that as the communication to the failed node is lost, securing the data can be done only by external method called fencing. So we have to depend on external method because the communication itself is lost in the cluster nodes, and hence it cannot heal it by itself. By itself, it cannot heal, and so there should be an external mechanism to do the healing part, and that is what is called as the fencing. And a fence device is an external device that can be used by the cluster to restrict access to the shared resources by the failed node, or it issues a hard reboot. So it can either stop accessing the shared resource, or it will initiate a reboot of the failed node so that it can come up successfully. So this is what is the fence device would do. Without a fence device, the data integrity cannot be guaranteed, and when the fence is in progress, no other cluster operation is allowed to run. So while the fencing is on, so cluster would be like uh, in a passive state. Okay, so fencing device types, we have power-based fencing, wherein we have programmatically controlled power supplies. APC is one which is being manufactured by a company called APC, and which we can control it through the program, and we can configure a STONITH device or a fencing device based on the APC power supply. So power-based fencing is one. So next one is storage-based fencing, which is called STONITH block device, which uses a shared block device. It could be a piece of disk that we can use to exchange messages between nodes, and allowing for fencing through shared storage access control. It'll emulate a watchdog to run between the nodes to monitor the health of the node and initiate the fencing if required. So this is what it will do during the fencing. When fencing happens, this is what it will do. It'll actually, the watchdog would keep monitoring, and then if something goes wrong, so it'll initiate the actions. So this is what SBD, I mean, every fencing device does that. The SBD is also doing that by means of having a block device. And there's another thing which is always that the manual fencing. So administrator manually power off the device, the faulty device, and makes it to bring it up after resolving the failure. So these are the things uh, that we can do. So here, this is the picture. There is a node 1, node 2, and we have the uh, shared disk. This is the SAN, storage area network, and we have some disks that are being shared. And apart from that, we have a shared block device that we can that we can create and make it part of both these nodes. And these shared device will act as a external device that will monitor the healthiness of the nodes, and the moment the healthiness when there's an event happens, so it will actually initiate the uh, fencing thing, and then it will bring down the one of the nodes, the faulty node, so that it will bring up the cluster in a proper shape. Okay. Okay, so we'll start with the fencing configuration. So there are two parts here. One is first thing is we will have to set up a shared device. So shared STONITH block device. So this is a device that we will have to create in the ISKC server. So second. This is my ISKC server. So currently what I'm going to do is this, I'm going to create a disk. So this disk, I'm going to create it in a location called var lib ISKC disks. Under this disk, I have created a under this I've created a directory called ISKC disks. That's a directory. That's the first step. And next, I'm going to create a disk inside this directory using the ISKC server. And the next step is to get into the ISKC server target CLI. Target CLI is a command to get into the ISKC server, and we can go to the CD backstores file IO, CD backstores file IO, and next one is to create the disk 01. That's the name of the disk, and the we want to create the disk under this directory, so we can give this command create disk. It's already created. I've created for about 2 gigabits. I've already created, so it's already exists. So it says that it's already existing. And now I'm going to go to ISKC directory, and I'm going to give I create the target number. This target number is also created again. Already exists. The target is already existing. So this is a command that we have to create. So now we'll go to the target under the TPG1 and go to the lens directory. So These are the targets that I have. So this is a target just now I created. And creating the disk 01 and the in the lens in the lens directory. So the command to do that is this, just to create. This is also existing already. I've already created. I'm going to create the ACLs to access the target. So under TPG1, I have to go to ACLs, and then we have to create the ACLs. So ACLs for both the nodes, these are the IQN numbers for both the nodes. So I have created using these two ACLs. So you can see I can create it like this. This also already exists. Two ACLs are created, and now I can exit.
You are referring ACLs as to what, Alex?
I'm sorry, Shafi.
ACLs
ACL
is being
ACL for access control list. So this is basically says that this target disk is accessible for the two clients, two nodes I have in the cluster. So I'm giving the IQN numbers that I have created in the clients. So the IQN numbers are created in this location. So you can uh, mm, after installing the client side. IQN numbers will be
inside ISCSI initiators, you are saying?
yes, ISKC. I
Where
forgot
is
the
this one?
path. Yeah, so there is a
It
IQN
is.
number for each of these nodes. So these IQN numbers I am giving it to the ACLs. So these ACLs are the access control list, which tells the server, ISKC server, that these nodes or these ISKC clients are qualified or eligible to access this stat disk. So that's the meaning. So
So
we have
where it is saved? Where is saved? ACLs are saved where? In server side or the storage side?
in the server side. ACLs
Which
are served.
location this one?
So it is in the target CLI. If you go to target CLI, and then if you see here, so the command prompts are different. So if you see here, so this is these are the two ACLs that I have given. So that is appearing over here. So this is specific to this target. This target is SPD01. That's the target that I've created as a SPD device. So this is the location.
But what is this target CLI? This is like an additional tool or
This is the ISKC server. Target CLI is the ISKC server utility.
okay. Is a add-on utility that you have to install it?
No,
Because by
it's
default
not.
it is not available, I think.
No, it's by default it is available. ISKC installation, you will get this target CLI. This is the way we can configure the ISKC server. ISKC server can be configured only through this target CLI thing. So target CLI comes up with a different set of CLI commands, and I mean the whole look and feel itself is little different.
Okay.
So
Okay.
yeah. So if you put if I put ls, some commands are common, but some commands are not common. So if you see, I have these many targets. So This is one target that I created for file system. One for the partition, one for the disk, and this is the one that I created for SBD, STONITH block device. So there are three things that I have created, and if I put exit, it will come out of that after saving it. So at the client side, what we have to do is we have to go and search whether we are able to discover whether you're able to discover it properly or not. So we give this command. So my SKC server is 172.15.0.17, and if I give this thing, so if I enter, so I could locate all three devices as I had shown in the SKC server. Same thing I'm going to do in the next node. My SKC server IP is 172.15.0.17. So here also I'm able to discover these three disks, and I can verify the status. So it is connected, and I can make sure I'm logging into the server. Senthil?
So far it is without fencing, right?
Yeah,
Without stonic.
I'm actually in the process of demonstrating STONITH, Senthil. So first thing is there are three kinds of fencing devices. One is power supply based fencing device. Next one is shared disk based. So shared disk based fencing is what I'm configuring. I'm currently, and what I'm doing is shared disk is what I'm trying to create. So there is a
Okay.
ISKZ server and a
After
client.
this, you will make a
Create the
condition
STONITH.
that.
I'll
Yeah.
create
Okay.
the STONITH in the cluster. Yes. So first
Okay.
I'm creating the shared disk right now. So the shared disk is available in the clients. So if you see here, so all of these things, both these clients, VM1 and VM2, send to is VM1 is my node 1, and this one is the node 2. So if you see LSBLK, you can see the 2G which is showing up here. 2G which is showing up here. This is in SDC. So this is the shared disk that we have just created, and if you see here, this is 2G which is appearing over here. So both these devices are appearing here. So next we'll continue with the next step, which is configuring the fencing agent. So configuring the fencing agent, there are a few tools that we have to install. So these are the tools: fencing agent, SCSI, watchdog, PCP0 conf. So there are three things that we may have to install in both the nodes. We'll have to install this. I'm installing this. I've already installed this in my both the nodes. So however, I'm doing it in one of the nodes just for clarity's sake. Okay, so the next after installing the required fencing agent and the tools, we may have to copy a script file, which is a very important script file, which is placed under user share. So the script file is present under CP, it is present under USR share cluster, and the script file is present and name is fancy SCSI check. So this fancy SCSI check, if you I'll open this and show to you. So in a moment, so this has a very big script which will do the actual monitoring. So this is the watchdog monitoring stuff that's being taken care here. So between the nodes here, this script will do the job of monitoring and taking the required action. And this script is we will have to copy into the watchdog service. So watchdog service configuration is present under etc watchdog.t, and in that place I'm writing it. So it's already there, so I'm not going to rewrite it. So I'm going to show what's the script is, how the script would look like. So this is how the script is, a very big script. So it comes by default when we install the fencing agent. So we'll have to copy it in the watchdog location, watchdog service configuration location. That's one. And the next step is to configure the STONITH property in the cluster. So this is where we are actually starting the configuration. So in both the nodes, we'll have to configure this. I've already configured it here. So on both the nodes, we are going to configure STONITH true. This is done. And next one is to, in one of the nodes, then we will have to configure the actual configuration of required for the fencing. So this is actually present the disk that the 2 gigabit disk is present in the SDC. So we need to find a unique number which is called WWN, and we can find this WWN number using this command. ls, or you can also put ls minus l. So this is the WWN number for SDC. So the SDC is nothing but the 2G. This is where is the SBD, that is the STONITH block device that we have just created. This is why we are looking for this number. Is this is a number which will never change. Even SDC or something SDB. Sometimes when we reboot, this SDC goes to SDB. So all things are happening. So it dynamically changes. So but this number doesn't change. So that's the reason we use this ID number. So this WWN number, and this is the number by which we can configure the SBD configuration or the fencing configuration. The configuration is, this is the configuration that we'll have to give. I'm copying this and I'm going to give this in one of the node. So if you see here, my WW number I have copied over here. So this is the WW number. So first thing is PC STONITH create IceKZ shooter. That's the name of the STONITH device, and the STONITH device type or the fencing device type is called fence SCSI and PCMK host list. So which are the nodes? These nodes, I have two nodes, node 1 and node 2. I'm listing them here. And devices dev list by ID. So this is the device. So device, I'm pointing it by means of WWN number. Just whatever I've found it, I copied it over here. Meta provides is equal to unfencing. Unfencing means once it is fencing is initiated, when it comes up, it should not again do a fencing. So it says that do an unfence when you reboot the faulty system. So that's a configuration. So it's already done. So it says already done. We can see the configuration by giving here by the command pc STONITH config SCSI shooter. SCSI shooter is the name of the configuration. Okay, so I have successfully configured the fencing configuration right now. So that's all about the fencing configuration. Now we'll start testing the fencing. We can see the configuration PCS status. If you see, so you will see 3 resources that we had configured initially. There is a file system. Next one is a virtual IP. Third one is the web server. And fourth one is the SCSI shooter. So the SCSI shooter is the fencing device that we have configured. So PCS status here. So same thing for device, for things are configured. So now what we are going to how to test is, there are 2 ways. What I'm going to do is remove the connectivity for the sent node 1 2 with sent node 1. So if you see here, this is my picture. If you see this picture, so there is a node 1 and node 2. So there's a connectivity between this node 1 and node 2. What I'm going to do is I'm going to remove this connectivity. So this is, I'm going to cut off this. I'm going to cut this off. And while once I cut this off, this will create a 2 independent nodes. So it will actually 2 independent nodes will be there. One will access the shared disk, another may not be able to access the shared disk, and it will create cause confusion. And this SPD that we have configured will be able to monitor this, and what he will do is he will actually reboot the node 2, and he will bring up the cluster again. So that's what we are going to see now. I'm going to demonstrate that now. So there are 2 nodes. So in the virtual environment, sent OSBM2. So this is my node 2. So in this network, and I'm going to remove this cable connected. So there's a virtual cable connected between these nodes. I'm going to remove this. If I put if the tick is there, so it means the cable is connected. I'm going to remove this and then click OK, which means now you can see my SSH will not work. And VM1, you can see previously you were seeing both nodes were online here. Now you can see only one node is online and the other one gone offline. So this is the status. And the SSH thing will not work because I have removed the connectivity. And if you see here, so this is my node 2. I am accessing the actual server, not using the SSH. So if you see PCS status, so it's giving error because it's not. He says sent node 2 is online, sent node 1 is not visible for him. So this guy is independent and that guy is independent. Both of them are not in cluster, but still they have the resources in hand for them to operate. So this is the dangerous situation. So we'll have to, so he's seeing pending fencing action, reboot of sent node 1 is saying for pacemaker, send node lost pending. So this what it is saying. So so now we'll bring up this connectivity back. So let me bring this up. And you can see the node 2 is has already started the rebooting. So reboot process is on. Node 2 is under reboot and it's currently rebooting and it will take some time. And once it comes up, the cluster will be completely back to its normal state. So currently the system is rebooting. Yeah, so this reboot is being initiated by the fencing. We've also put back the cable connection, and this fencing is initiating the reboot, and it's going to bring up the cluster, everything back to its original position, and all the resources and everything will be back completely, will be restored back. There is a explicit command also which you can use to test the fencing, and we can issue this command pc STONITH fence sent node 1 dot chosen dot local. So this is the node 1 makes the node 1 automatically reboot. So by explicitly saying that this should get manual, this as if it's like a manual thing. What we have just shown is a real-time scenario testing. Okay, so I think, yeah, so the node 2 is back. Well, yeah, node 2 is back now. Yeah, all the services are back. So even node 1, all the services are back, and this is the virtual IP upon which we can still see the web server, which is up and running. So upon which the virtual server is running. So virtual IP, the web server is running and it continues to be available after the fencing operation. Okay, so that's about the fencing. Next one is Quorum. We'll see what the Quorum is. Quorum, to maintain the core cluster integrity and availability, HA cluster uses the Quorum concept to prevent data corruption and loss. So it's very closely related to the fencing just now what we have seen. However, we'll see a little deeper of this quorum concept. Cluster quorum is nothing but majority in the cluster. So that's a basis. It goes by the majority of the nodes that is available. It has a voting algorithm to handle the split brain condition. Split brain condition is the one that we have just now seen. We had two clusters, one node, both of them is supposed to work together to access the resource. Whereas when there is a communication breakdown happens between these two nodes, so each of these nodes assumes that they are independent nodes and they created two clusters on its own, and they try to access the uh, cluster resource, so which is called as the split brain scenario. And this is what we will get avoided or will get removed by quorum. So cluster has quorum when uh, so we have just seen two node clusters. So in case if we have 6 node, 8 node, 4 nodes, all things will behave little differently. So the cluster has cluster need to have the quorum to be active and operate. So if the quorum is not there, so cluster won't be in active state and we will not have the resources as well. So these clusters need to have the quorum. So what is a quorum? Quorum is actually we should have during communication breakdown or something. So we need to have at least more than half of the cluster nodes online. So that's what is the formula here. If the quorum is not there, the cluster stops all the resources by default policy. The default policy would say all resources should be brought down unless otherwise we could make it customized. So cluster quorum is established by this voting system. When a cluster node lost the communication with the cluster, the other working nodes can vote to isolate the failed nodes, and if required, fence node for servicing. So this is what we had done just now. We had seen cluster and applications can work only with the exact quorum. So that's what it is. Okay, so coming to basics and calculation, quorum, as I had mentioned, so majority of the nodes should be available for a cluster to be operatable state or in an active state. So there are three ways of quorum calculations are done. So one is the majority quorum, second one is the custom quorum, third one is a node weighting quorum. So I'll touch up. I'm going to give more focus on the majority quorum, and all of the remaining things I'm going to give a little bit of information because custom quorum is not followed, uh, is not advisable, but still it at the exceptional scenarios these things might be required. So majority quorum is what I'm going to discuss now. Majority quorum, each and every node will have a default vote, and this vote will be of value 1. So total vote will be the cluster. If you see the total votes, cluster nodes that are active. So how many ever nodes that are active, that will be the total votes. And expected votes is equal to total votes at the initial state but modified later. So expected votes may be different because of failures and things like that, but initial time both the expected votes and total votes would be same. Okay, let's take an example here. There's a 3 node cluster, so totally it is 3 node. First 3 node cluster, and all 3 are in active state, and there's no failure, and the quorum is 3 and is completely functional. There's no issue here. Second state, so total nodes 3, active nodes are 2, and there's a failure in one failure node, and we still have the quorum. So the formula is we should have more than half of the nodes should be in active state for the quorum to have, and hence thereby we will have the cluster in active state. So if we have lesser number of nodes, then the quorum will not be there and we will not have it. For 3 nodes, so we need to have at least 2 nodes to be in active state for the quorum to be formed, and the cluster would be in functional state. So we have quorum number is 2, and we will have continue to have the cluster working. So now let's take the example. So third state, 3 nodes out of 3 nodes, 2 nodes are in failed, and only one is inactive, and quorum is 0. So there's no quorum at all, and so it will become non-functional, and the whole of the cluster and its resources will be stopped and it will not function. And the same thing, if there are no active nodes, it will not function. So this is how typically a thing cluster quorum would work for a 3-node cluster. So the basic thing that we'll have to remember here is, to form a quorum, we need to have more than half. So if we have a 7-node cluster, we should have more than half. That means for a 7-node cluster, we will have half is like 3, and we should have at least 4. 4 nodes should be in active states for the quorum to function. Just 1 minute, just. Okay, so this quorum things are actually being taken care by means of a configuration that is there in the chorusing.conf file. Okay, this chorusing.conf file is a configuration file record for the chorusing, and this configuration file is not generally advisable to edit. So it will get formed whenever we create the cluster. So based on the nodes that are available, so the chorusing.conf file is generally created by itself, unless otherwise we definitely want to make any changes, and if you're very familiar about the changes that we want to do, so it's okay to do it, but otherwise it's not advisable to make any changes in the chorusing configuration. So chorusing configuration, if you open and see, you will have a directive called Quorum. So this is the vote quorum is a service that is there in the chorusing, and this is the service. This is the component which takes care of the quorum part. Quorum has been taken care by this vote quorum service. Vote quorum service. This is the service that is doing this job. And if you see here, there are a few things here, and provider is chorusing vote quorum. This will be there, and 2-node is equal to 2-node colon 1. This is, we will have to specify, this is an exceptional case because we have a 2-node cluster. So generally it's not a advisable thing. 2-node cluster is what is being used here. We use here. So by default, by itself, you will create this 2-node cluster. This specify that there is a 2-node cluster, which is a special case. So there's an auto tiebreaker. So I'll talk about this auto tiebreaker in a minute. And so last man standing, so allowing cluster operation even with one active. So these are some configuration, these are some customized configuration that might be required. So it'll all be created. If you want to make any changes, we can do so, but otherwise it will created by default. So this vote quorum service is present in the chorusing.conf. Custom quorum configuration. I talked about majority quorum. So now it is custom quorum configuration. Some of the custom quorum configuration I'll talk about. There's a configuration called PCS property setup no quorum policy. No quorum policy. There is a no quorum policy settings that we can make. We can say we can ignore. So if we say ignore, means cluster continues to run when quorum is lost. Even when there is no quorum, we want the cluster to run. So we can say, please ignore the no quorum policy. So do not worry about the quorum at all. Just go forward and have the cluster active, even if you have just one node. So this is one configuration. So apart from that, by default, it will be stop. So if you see this configuration, by default, it will be stop, which means if there is no quorum, stop the thing, stop the resource. That's what is it. That's what it will be. If you want to make any customized thing, we can make it ignore, we can have fence, demote, freeze, ignore is what we have discussed.
And what is the command to see the current configuration?
PCS property status.
Yes, PCS property.
Status, one second.
Property show no quorum. Regarding quorum only. I think he's saying set no quorum, right?
Set no quorum policy. I think
Yes.
PCS property, I found somewhere. PCS property describe, I think. PCS property describe no. Yeah.
What is this one? So this is property.
No quorum policy, but this is actually this is a help thing. So piece is property, no quorum policy. Piece is property, default is also you can see.
Default.
Default. No quorum policy stop.
What is that? Please show me again the command. This is property.
Piece is property defaults.
But it will list the all.
Yeah, all the configuration of the pieces properties.
Defaults or default? Default.
Defaults.
Okay.
Defaults.
Then.
Okay. So we'll we have seen the custom based quorum configuration. So now we will see two other configurations. Node level configuration. So there are few configurations that we can do on node basis. So for different nodes, we can give some. There's a concept called node weight. Node weight. There's a configuration called node weight. The mechanism to influence quorum calculation. So for example, if you see in a two node cluster, one for first node 1 we give a weight of 2, and node 2 we give a weight of 1. And if node 2 goes down, it still has a weight of 2 to maintain the quorum. So even if node 2 goes down, the cluster would be in operative state because node 1's weight is 2. So we'll have the cluster still in functional state. So similar, another example, in a three node cluster, if suppose we have the node 1 weight 3, node 2 weight 2, and node 3 weight 1, and if both node 2 and node 3, both these things, node 2 and node 3, goes down, so that means 2 plus 1 3, that going off, n1 will nf will have enough weight to satisfy quorum, because for a 3 node quorum we need for 3 node cluster we need at least 2 active things. So it's very similar to the vote. Node weight is very similar, but it can influence. So it's all, the same configuration here. The configuration is the concept is the node weight should be more than the uh, half of the cluster nodes. So that's the formula here for the node weight as well. This is also can be used for customizing the quorum. So how to set the weights? So weight is there's a command called PCS node attribute, and we can give the node, and then we can give the weight is equal to 3. And now we can see PCS node attribute. That's a command which we can say. I'll
This
just
is
quickly show it to you. Show it to you in a minute.
So this is how you are defining the weight of a specific node.
Correct. That's correct. So this is a node 1. I'm configuring a weight of 3. So
This is mandatory to define, or without this we can work?
No need to it's not mandatory. So basically, if you want to configure, it will have an influence in the quorum. So I talk to you about quorum. So if you see the example here, in a for example, 2 node cluster. For example, node 1 we have a weight, we have configured a weight of 2, and node 2 we have configured a weight of 1. Okay, so totally in this cluster we have 3, weight of 3. And suppose n2, node 2 going down, so that for some reason n2 becomes faulty, but still we have one node which is active. But generally by default, based on the majority quorum, so since one node is already gone, we lose the quorum and the resources will be stopped. So that's the default scenario. So what we are doing it here is changing this default scenario by increasing weightage of one of the node. So we have increased the weight of one of the node, which is node 1 to 2, so that even if the node 2 goes down, node 1 is still having the weight 2. So quorum will still be there, and then the cluster resource will be in active state. So that's the significance of configuring node weights. We can configure node weights only when we require. So if we do not want the cluster resource to stop, just because having one node, just because not having a quorum. So if we have a 3-node cluster, we need to have at least 2 nodes to be in operative state. So if we do not want this kind of thing, we can configure a wait, which by to a resource, to a node of higher value, so that node will be given more importance. Unless or otherwise that node is going down, the cluster would not go down. So
Okay.
that's
Okay.
the concept.
Okay.
That's
Okay. So that the concept is clear. So, but where is this configuration file, Alex? If you want to find this configuration file.
Yeah, it is in PCS node attributes. So I've just configured this PCS node attributes
Oh,
and
yes.
node 1 local variables. Then if you want to see
Okay.
this PCS node attributes, so this is node attributes. So all related to node attributes, you can configure here. So I just whatever I configured here is showing up here. Wait 3.
Yes. But I can see it here somewhere in the backend configuration file or no?
I don't think configuration file. Node configuration file. I don't think
No.
we have any specific configuration. We have corosing.conf.
And which is the main configuration file for this cluster and STONITH?
So
The main configuration file.
main configuration file. This is the configuration file, but they
Corosing,
don't
okay.
suggest to corosing.conf. This is a configuration file. This the totem is the protocol which is taking care of communicating between the nodes, and we have the node list node 1 and node 2, and quorum. This is the quorum service that I talked to you about. Vote quorum service. This is the thing that. So but and this is the log file location. So this is what is the quorum configuration. It's a very important configuration file, and this configuration file we are not supposed to edit it. So this is one thing, we are not supposed to edit it. This gets created by default when we create a cluster. PCS create is a command. PCS create cluster. So this is the command that we use. So when we do this command, so this command will create this corosing.conf based on the nodes that we have authenticated for this cluster. Just before this step, we have authenticated two nodes or 3 nodes or whatever amount of nodes we have authenticated. He is going to search based on the nodes that are authenticated for this cluster, and then he is going to create this corosing.conf, and he creates it by default with this. And unless otherwise we want to make any changes, we don't want to change anything in this configuration.
Yeah, but that in that corosing.conf file will show it. So these attributes, the PCS node attributes are available there.
Node attributes are not available. Yeah, node attributes are not available. So node attributes is here. So this is all it is. This is all it is having. Node list, node, the first node, and it is having a node ID is 1. Second node ID is
and
2.
what you define, what to node 1 you define it. So that's saying that always prioritize to node 1.
If we want to prioritize, we can give the node. We can give the weight. Just now we had given. No? So if you want to give priorities higher priority, so we can give node 1 higher weight. So unless otherwise node 1 goes down, the cluster will not go down. So cluster will still be operative.
So this is optional configuration. Yeah, if you
optional.
want to
It's an optional configuration. It's an optional configuration.
okay.
Yeah. So that's about it. Auto tiebreaker. So this is one other concepts. Oh, just I'll take few more minutes to complete. We started a little late, so just want to complete with this. So I just have complete. I'll just take 5 more minutes. Okay, right?
Yeah, sure.
So auto tiebreaker. So in scenarios like if you have even number of cluster nodes, So if you have like 4 node cluster, 6 node cluster, 8 node cluster, on all of these things, suppose if there is a breakdown happens, so suppose if you have a 8 node cluster, if there is a breakdown happens, it creates 4 in one side, 4 in another side. So this creates a 2 cluster, and she will not have the majority. Quorum will not work here because both sides they have the majority, and they still get into this split brain scenario. So we will have to break this only by this auto tiebreaker is equal to 1 is we can see that is present in the forcing.configuration file. So that scenario we may have to use node wait, or we can add an external quorum device, or we can have the arbitrator node. So all of these possibilities are there to sort out this auto tiebreaker issues. So location constraints. So resource level configurations, we have constraints which we can set. Constraints or nothing but for cluster resources meant to change the behavior of a resource. Constraints are critical in pacemaker for controlling the behavior of resources in your cluster. They define rules, but where a resource should run, how they are related to each other, and things like that. These are the different constraints we may have to if you want to put for these resources, we can do so. So for there are 3 kinds of the resource constraints. One is the location constraint. Second one is the ordering constraint. You asked about the ordering thing, so there's an ordering constraint. Co-location constraint. So what is location constraint? Location constraint, we can say resource running in a specific node. We can say this resource should always be running only in this node. I have 8 node cluster, and I want this resource always to be run in this node. That is that kind of configuration constraint we can give. Ordering constraint, we may have to tell except this the shared disk is available, so this service should not be available. So that kind of configuration we can give. The configuration command is also given here. PCS constraint order resource 1 then resource 2. So this is a configuration we can give. We can give co-location constraint, so placement of resources relative to others. So if this resource is available, you may have to say this resource can also be available. So if it is present in this location, so this will also be present in this location. So co-location constraint. Score, we are configuring during constraint. The score determines the strength of the order reference, positive for the desired order, negative for the reverse order. So we can configure the score accordingly, whether to take it in the positive order or negative order. So these are the constraints that we can configure. So last one is the web interface. So web interface can be accessed from any of the nodes. The port number is 2224. Okay. I don't know why it was not coming earlier. Now it is coming. So this is the UI interface for the cluster, and username and password is HA cluster. That's the default username that comes up when we install high availability. Password is something which you would have configured. Okay, so it is opened up the user interface now. I may have to add all the required
You're like trying to view the existing cluster now?
Yeah,
Or
so
adding?
I will have to set it up and then we'll have to, yeah, so add existing cluster. So all things may have to be, if you want to do it over here, so we can do that here as well. So chosen underscore cluster, that's a
No,
cluster
you're
that
not
name.
creating the cluster, right? You're just trying to set up the view appearance of this.
View, correct. I'm just setting up the view. There are two nodes saying has quorum.
What can you show us how you set up this web interface? The port numbers, how you define it, how you configure in the server?
So nothing much. So 2224 is something on the firewall alone. I think I remember I had given.
So this has to be, you are doing it for all three servers or only one server is enough?
No, all three.
Okay.
So I
Okay.
think it is on the high availability port. It's all coming at nothing necessary, nothing specific we may have to configure in the servers for getting this HA web interface. So it comes by default. So you can access in any of the nodes using this port number. This is what we have to be clear.
Triple
Four.
two four.
Four.
One
So
second,
that's
please.
yeah.
By what is that IP address? The virtual IP address or the
So this
node
is
IP
the
address?
no. This is node IP address. This is node IP address. SPD is also showing up here. So whatever I had configured SPD configuration, all sorts of configurations you can see over here as well. SCSI shooter fence device that I configured is also being shown here.
What is the URL? Just what is UI HTTPS? No, but
Yeah.
how from the server, how we can make sure this is enabled?
From the server, nothing. We don't need to do anything specifically. So only thing is we need to specify the username password. So we would have done this as part of creating the nodes and authenticating the nodes.
Yeah, HA
So
cluster normally will have the credentials assigned. I agree.
credential, yeah. So HA
But
cluster. So when you when you install the high availability, HA cluster username is there. Password is not there by default. So we'll have to give the password by ourselves. Once we give this password, enter this password, we will get this access.
yeah, but at least we should get this login window, no? The web page login window.
We'll definitely get. We'll get by default. It will get. We don't need to do anything specific.
Triple two four, not yet. So because this will be important or good as well. Just if we can wait, we'll try to check something. Triple two four for server page. And
Yeah.
no, come on. This I don't get this one. Firewall.
You. What's your question, Sophie?
Oh, we are
Firewall.
trying to see this web GUI. But
In the
using
thing.
this port, no, we cannot.
Yeah, it's not going. So are you sure you have made this high availability enabled in this firewall?
So where you are, can you show us where you have checked this one?
Or did you?
Okay, 1 second.
Are you
Let me
seeing my
check.
screen? Are you
Yeah,
seeing
now
my
I can see.
screen?
Yeah.
Are you?
I was. 1 second, please. Let me check. So firewall CMD. One second, please. So what we can do is let's double check. So once what you're saying is once we ensure this high availability is part of this firewall. Service firewall. Okay, then where is the port here? Not specified.
No, it's not specified. So mostly the high availability service will have the required ports. I'm assuming. So this port is actually 2224.
Okay, we will check on this because I think we
It
will
is not
check and
working. You're saying it's
yeah,
not
it is not
working in
work.
your end.
Yeah, I don't say it, but we will check what the service what you are saying.
So maybe this 2224 is a customized setting. So is it maybe so 2224 is a default setting? Maybe you would have customized to some other number. Maybe that could be a possibility.
We'll check. We'll check on this one.
Okay.
Okay.
So
Anything else for today or
yeah,
what?
yeah, I thought of covering Apache web server, but still I think we cannot do that today. So we'll finish it.
You're happy for today? Okay, for
Yeah,
us.
yeah.
So for us. But what is the target? You think we can today?
I
This week.
target to complete Apache web server. So do you have time? Is it possible to maybe have time? Maybe I'm not sure. So it may take like 15-20 minutes time. Apache web server and virtual hosting. I think it's already late, so we'll stop here. So maybe we'll.
Okay, it's up to you. It's up to you. Let's see.
From your side, is it okay? Is it okay for you?
15 more minutes is okay. Should be okay.
Okay, then I'll complete that also. Then
okay, but this topic, please, we will try to check later offline, and we'll try to come back to you to see any clarification.
oh yeah, sure.
Achieve a page.
Sure. Whatever related to cluster, you can come back to me even after completing the training as well. So you're most welcome.
Okay, thank you.
Okay, next one is web server, Apache web server. So that's the one thing. On to it's a very common topic. So that's the reason I thought it's not a big topic. So Apache web server. So introduction, we'll see what's an Apache web server, basic working. What is virtual hosting? There are three kinds of virtual hosting: name based, IP based, and port based. So all of these things, virtual hosting, how to configure virtual hosting, and then we'll see configuration and demo. So these are the things we'll see. Apache web server is a network service that serves content, typically web pages, to a client over the web. It uses a protocol called Hypertext Transport Protocol. It's also called as HTTP server. It can also be called as HTTP server. Developed by Apache Foundation, so open source web server. So when a website's URL is entered in the browser, it sends a HTTP request to the web server, which then sends back requested web page. So the web server replies back to the client with a web page. Web server can be used for web hosting, can be used for load balancing, can be used for doing a web application. These are the benefits or things that we get out of the web server. So, so this is a picture that you can see working of a web server. So user is typing the username or the website name in the browser. So it goes into the DNS server. DNS server is giving him the IP address, and the user's PC is mm, receiving the IP address, and he is trying to access the web server with the IP address, and web server gives back gives back the response, that is the web page, and web page is displayed in the web browser. So it's as simple as that. We'll see how it works. So before that, we'll see virtual hosting, What is about virtual hosting? Virtual hosting is a technique that enables you to use one server to serve different content. So we have just only one server, we have. We can use to we can use to serve different content based on either the domain name or IP address or port number in the request. So I repeat, so we have just only one server, and this server can be accessed in three different ways, and these three different ways by the three different methods are used by means of name based, or it is IP based, or it port based. So the way we give the request in the browser, so the request goes to the web server, and the web server, based on the request type, so is going to fetch the content so that are stored in different locations. So if it is a name based, we have different document root. If there is a IP based, we have different document root, and we have this port based, we have different document root. Different document root means that's where we have our web page contents stored. So based on the request, so the web server can redirect to the appropriate web content to fetch from, and is going to give it to us like that. So that's what we are going to see now. Apache looks at the host header and yeah, do the changes. That's what I told. Each virtual host has a different server name. We can have a different server name. From the user's perspective, we can have a different server name. So, but all is pointing to the same server, same physical machine, but it to a different content. But user's perspective, it appears as if it is a different server. Is website, I mean, the URL looks different. So three different URLs, but it'll all pointing down to the same machine. So that's what it is thing. So virtual hosting, we may have to configure the document root and the server name as settings. We even if they all share the same physical machine and IP address. So we'll see that name based, IP based, and port based. There are three virtual hosting types. Look at looks at the host header to determine the virtual host block. There's a different virtual host configuration. So as I had told, so when the HTTP request comes, so the web server will find out based on the request type. So the request coming based on the name, so the type will be little different. If it is coming based on the IP, it will be different, and port, it will be different. Based on it, respective virtual host configuration block is being selected, and hence the different document root is being selected. Okay, so anyway, we'll see the configuration. We'll get to more details. There are three kinds of configuration, two configuration files. One is the main configuration file, which is present in this location. So this is the location. Sorry. So this is the main configuration file, httpd.configuration. So that's the main configuration file, and all other configuration virtual host configurations needs to be placed inside this directory. So this is a very mandatory requirement. So this is an additional configuration file. The main site configurations will be present under this location. If we want to see whether the configurations are done correctly, so we can give Apache CTL config test. So this will tell us whether the configurations are proper or not. Okay. So there are different configuration directives in the HTTPD config. So maybe I'll open. I'm using a Fedora server here for the web server. So to install the web server, you may have to give yum install httpd. Since I've already done, so saying nothing to do. So if you see httpd conf, and this is the main file. You see this file, this is the configuration, main configuration file, And if you see, there are many directives here. So I'll just quickly browse through the important directives here. Listen. So listen is 80 is the port that comes by default. I've added another port which is 8090 for port-based virtual host. We'll see that in a minute. And all other things I've kept it as user. The user and group is Apache. When we install the create the directory content, we may have to give this Apache ownership. So I'll talk about this in a minute. And server admin, I've called this server as chosentraining.com, and admin is admin at the rate of chosentraining.com, and my server name is www.chosentraining.com. And what other things? So I have kept it. So this is the document. This is the directory. Slash var slash www html. So this is the document directory, and under which he is going to look for index files. So that's mentioned over here. Index.html is the default file which he will look into, and other things I have not changed. So this is the main configuration file. I have not changed anything else. So next thing, document root virtual host. So virtual host virtual host configurations are present under conf.d. Under this, we have the virtual host configuration files. I have chosen training.configuration file. So this is the main site, where whtml, that's the location. Under that, I have the server name, server alias. Server alias is, suppose if we give chosentraining.com, that time also it will look into this directory. We give www chosen training, so server alias, so it will still go and fetch this directory. So this is the main site, and I have another site which is called site1 dot chosentraining.com. So this is another document root. This is document root for site1. This is the name based virtual hosting site1, and this is a different location, and I have a different website here. So that's a site1. Suppose to access this, I need to give site1.chosentraining.com. Site2 similarly, and I have IP based chosen training. There's a virtual host, the configuration that I created. So look here, that's a one important configuration change. Here it is 172.15.0.101. So this is the IP, this is a different IP, but same machine. So IP based configuration, IP based virtual hosting works based on different IP, but both these IPs are existing in the same physical machine. So I'll show the different IPs that are existing in the same machine. So I've configured the virtual host here, and the name of the server name is ip.chosentraining.com, log file location and all that. And if you see port based virtual hosting, and port based virtual hosting is 100 and 8090. Default port is 80. Here it is port based. If it is 8090, then I'm saying we'll have to go and look into the root document root directory under port. So I have different files under this location, different document root directory location. Under HTML, if you see, I have IP port, site1, site2. There are 4 document roots. Each are different. Each location is showing different uh, different web page content. So for example, if you see site1 index.html, there is a content, and you can see it says site1 chosen training. And if it is site2, different content. And if it is port, there's a different content. And if it's IP, I have different content. So I've given all of these different contents now. Okay, so now Now, this is the web server. So in this web server, I have configured multiple IPs. So if you see here, NMTY, this is my. So I have configured three IPs here: 172.15.0.100, 101, 102. Three IP addresses are configured on this for this interface. So that I can have multiple websites based on the IP, uh, different IPs, but all pointing to the same machine. So that's the thing. Okay, so now mm, ah, so this is my DNS server configuration. I'll just quickly show DNS server configuration zone file. Show the zone file configuration. Okay, so this is my zone file configuration. If you see here, so my name server is present in this 172.15.0.11, and my web server is in 100. So that's the one that I just now showed. This is the one.
The screen is showing the same slide, Alex.
Oh,
This is what you're explaining.
no. I'm actually showing my screen. Sorry, I don't know. I'll share it again. I'll share it again. Just a minute. So, do you see the screen now?
Yeah, now we can see this.
Oh,
We didn't see the previous one. Yeah.
previous one. Okay. So what I was showing is, okay. This is what I was showing. So this is my web server. I'll just repeat anyways. This is my web server, and this web server is present in this 172.15.0.100, and I have configured multiple IPs here. So if you see, for this interface is mistakenly deactivated it. Okay, if you see here this interface, I have configured multiple IP address for this interface. So 172.15.0.100 is one IP address, and I have configured another IP address which is 101, 102. Multiple IP addresses I have configured. The reason is to have the IP based virtual hosting. So that's the reason I have configured multiple IP address for the same interface. Uh, okay. Okay, so in the web server, so I have configured, I'll show the main configuration file, which is present under httpd.conf. http.conf. So this is the main configuration file for the web server. And if you see few important directives, I'll just browse through. So first thing is actually the port that it is listening to. By default, it will be listening in the port number 80, which is TCP 80. I have added one more port, which is 8090, which is a customized port to have a virtual host based on port. So for this purpose, I have configured this 8090. And there's a user group, so these are all by default. I've not changed anything. So server name, so I have given my own server name, just chosentraining.com. That is one thing. And document root, so this is the document root for the main site is chosentraining.com, so that's the main site. This is not the virtual site, this is the virtual host, this is the main site. Virtual main site's location is where www html. And yeah, so there is no other. And the default, by default, into the document root, it is going to look for the index.html file to start with. So if we change anything here, so it will look for that kind of file in that document root. So by default, it will look for the index.html file. So that is the thing. Okay, so to configure the virtual host, we'll have to go to conf.d, and under that we will have to configure, we'll have to have different files for different virtual hosts. So for example, I have site1 chosen training.conf. So this is meant for name based configuration file, name based virtual hosting configuration file. So virtual host is a directive, and all IP address, I have not given any specific IP address, star colon 80, that's the default port. And server admin, so this is an admin IP address. Document root, so this is where I'm going to have my site one's specific web content. And my server name is site1.chosentraining.com. Server alias is site1.chosentraining ww. Sometimes we may give with ww, sometimes we may not give the ww. So to handle both, we can give server alias. This is the site1 virtual host configuration. And if you see the similarly, we have IP based, IP chosen training. So in the IP case, so I have configured 101. So I had two multiple IP addresses configured for one single interface on the web server. For one of the IP address, I have configured here 101.80, same default port. And the IP address, I mean the website address, the server name is ip.chosentraining.com. And the document root is this. Document root is where I am going to keep my web content, ip.chosentraining.com, all that. So likewise, I'm going to have the same thing for port chosen training, and I have a different port is this is the IP address is same. Port is 8090. For this location, I'm having this uh, configuration. So also all related configuration for virtual host is done. So once we have the configuration, we have to restart the HTTP server, or we may have to give Apache ctl config test. So this is going to say whether the configurations are done correctly or not. So it's all done correctly, and so it says syntax okay. Now let's go to the bind server or the name server. So name server is origin is the chosentraining.com. That's my domain. State of authority, these are records that we had initially, and name server's IP address this, and my web server's IP address is located in this location. www, that's a web server IP address main site, which is located in 172.15.0.100. And these are all the virtual host configurations in my web server. So So if you see all configuration, site 1, www.site1, site 2, site www.site2, all of these are configuring with the same IP address, except if you see IP and wwip, so it will take 101. So all other things are going to go with a 100 only. Okay, so that's a configuration on the name server. So pretty much all done. So if you want to check whether it is working fine or not, go to next node and then say dig 172.15.0.11. So this is my name server, and I can see site1.chosentraining.com.